So you baked a pan of brownies, and you gave a quarter of them to Susan, and you gave a quarter or a sixth of them to Patrick. How much of the original pan do you have left? Okay, that's what the question's asking. And again, this is pretty much like the playground problem that we did yesterday. So, here's where a lot of us began. And I want you to start to think about why what we're doing is wrong. Like, when I start writing something down, what am I representing? So a lot of us started with this. We took 1/4 and we subtracted 1/6. Okay? Here's the issue with starting with this. This particular problem says you are starting with 1/4 of the pan. And from 1/4 of a pan, you're giving away 1/6 of what's left. Well, we're not starting with 1/4 of the pan. How much of the pan are we starting with? We're starting with the whole thing. Okay? So that's why we can't just do this subtraction and say, hey, my answer is 1/12. I did like that a lot of us knew how to do that problem because that's what we've been talking about. We found a common denominator, which was 12. We made it 3/12 minus 2/12 and got 1/12. Okay? But that is not what this question's asking us to do. So, let's start with this just with numbers, and then we'll go back to the picture problem here in a minute. What I want to figure out, first of all, is how much I gave away. And again, we're not talking about how many pieces I gave away. We're talking about how much of the entire pan I gave away. So somebody tell me, what's one quantity that I gave away? I gave away 1/4. And I also gave away what? 1/6. So if I know how much I gave to Susan, and I knew how much I gave to Patrick, how much can I figure out that I gave away total? I would need to add those two together. Okay, so it's actually the complete opposite operation that we just got done talking about. So what I want to actually do is add these two together. Okay, right here, this value is representing the total amount given away. Alright, now we need to actually find the sum of this. Now again, even though you guys found this difference of it, you subtracted, you've done a bulk of the work. So, we know that we need to find a common denominator. Okay? I am not always going to just do the quick easy trick, which is multiply by 6 and 6 and 4 and 4, because we're not going to get used to anything else. I'm going to always try and work with my LCM, least common multiple. So what's my least common multiple of 4 and 6? 12. That means that I need to multiply my first equation by what? 3/3. And I need to multiply my second equation by 2/2. So, we'd have 3/12 plus 2/12, which is a total of 5/12. But again, what does 5/12 represent? This is what we gave away. The question's not how much we gave away, the question is how much did we have left? Well, again, how many 12ths did we start with in this problem? We started with 12 of them, because the entire pan was full. So, we started with 12 12ths, and we're giving away 5/12. So if I know how much I started with, and I know how much I gave away, I can just subtract those from one another. Okay? Well, 12 minus 5 is 7, and we keep the denominator as 12, so the amount that we gave away in this particular problem is 7/12. Now, if I'm going to draw a picture for this, we want to think a little bit ahead on how we would draw it. Here's my big 9 by 13 inch pan. Okay? I could break this up into quarters, because it would be very easy for me to see how much I gave to Susan. But the problem with breaking it into quarters is I don't know how to represent 1/6 of that. Does that make sense? So when I'm going to break this up using a picture, I want to be able to figure out a nice easy way to give away a quarter, but I also want to figure out a nice easy way to give away 1/6. So when I'm cutting this up, how many pieces should I at least have in this problem? I should at least have 12. Okay, why? Because 12 is a least common multiple of 4 and 6. I could draw 24 pieces. I could draw 36 pieces. But I like to draw a multiple of 12. So here I've got 2 pieces there, and then we're going to break this now into think of this as, well, we'll cut this pan down this way, right there. Perfect. There's my 12 pieces. Okay? Now, a quarter of those are going to Susan. How much is a quarter of this? If there's 12 total pieces, how much is a quarter? 3 out of the 12 pieces. So these 3 pieces here are all gone. I gave those away. Now I want to give a 1/6 of them to Patrick. How much of this entire pan is a 1/6 of it? 2 of those. 2 12ths. Those 2 are going to Patrick. So, how much do I have left? 1, 2, 3, 4, 5, 6, 7 12ths. If I broke this into 12 equal pieces, I have 7 of those 12 pieces left because I gave away the other 5. All right, here's your next one. We're going to work a lot on story problems today. So, for the school sports day, a group of students prepared 21.5 gallons of lemonade. At the end of the day, they had 2 5/8 gallons left over. How many gallons of lemonade were sold? Now, one of my suggestions anytime that I've got a story problem, especially if my numbers aren't quote-unquote nice, make a problem easier in your head and ask yourself what you're going to do. So let me ask you this scenario. If I made 10 gallons of lemonade and I have 3 gallons left over, how much did I sell? 7. How did you figure that out? 10 minus 3. No different now, except we're starting with a different amount, and we have a different amount left over. But if I'm doing a subtraction of 10 minus 3 to find that answer, then I need to be doing a subtraction in this one. We're going to begin with how much we have started with. We have 21.5 gallons. And from this, we're going to subtract 2 5/8. Okay, how much I started with, how much I have left should tell me how much I sold. So yesterday, this was one of our new ideas. Adding and subtracting mixed numbers. What's the first thing we're going to do? We're going to add or subtract mixed numbers. Even before that. Change to impropers. So, 21.5, 2 times 21 plus 1 should give me 43 over 2. Okay, from this we're going to subtract 8 times 2 plus 5, which is 21 over 8. Now that we've changed them to impropers, what's the next step? Find a common denominator. Now I could multiply the first one by 8 over 8, the second one by 2 over 2, but that's again going to actually create more work here. Least common multiple between these is 8. So I actually don't even have to change the second fraction. I can just multiply the first one by 4 over 4. So when I do that, this is now going to give me 172 over 8. And from this, we're subtracting 21 over 8. So if I take 172 and I subtract 21, that should leave me with 153 over 8. Oh, sorry, 151, yep. Over 8. Now, what do we have to always make sure we do? Try to reduce. Now, my only factors of 8, other than 1, and remember, it doesn't do us any good to divide it by 1. The only factors of 8 that I have are 2, 4, and 8. Do any of these go into 151? No. How do you know that? Because it's odd. And if these numbers are all even, then this would have to be an even number for those to go into them. So this is it. And again, I'm not expecting you or requiring you to change this back into a mixed number. If you wanted to, then absolutely you could. Okay? And you could get an idea of how many gallons you have left. Sometimes I would suggest to do that to see if this answer actually makes sense. Because here's what I'm thinking in my mind. I have 21 gallons, just a rough estimate. And if I were to have 2 gallons left over, how much should I have sold? 19 gallons. Now I have a little more than 21 and I've sold a little more than 2. I should have a number somewhere around 19. So if I were to take 8 into 151, how many times does 8 go into 151, guys? 18 times with a remainder of 7. You guys tell me, 7 or 8? 7. With a remainder of 7, would this seem reasonable? Yes. Yeah. We're pretty close to 19 gallons here. So changing it into a mixed number is a good way for you to be like, yeah, this now seems reasonable. Okay, but otherwise you can 100% leave it as a mixed number, or improper. All right, last one. Should be horses, not hoses. The wild code. All right, let's go. Alright, this problem is pretty much like your brownie problem. Okay, you know how many are the first type Arabians, you know how many of them are thoroughbreds. We'd like to know how many of them are the other type. So, what do I need to do with my 1/4 and my 2/5? We need to add those two together first. That's going to tell us how many are the other types. So if I'm going to add these two together, I need to find a... Okay, now this is the scenario where I can just go ahead and multiply the first one by 5, the second one by 4, because that is the least common multiple of 4 and 5, it's 20. So this now becomes 5 over 20. This becomes 8 over 20. So this is a total of what? 13 over 20. Now again, what's this number represent? This is the other types. So if 13 of the 20 breeds, sorry, I continue to be corrected over there by our horse expert in the room, okay? If 13 out of 20 of them are the other breeds, how many of them are the breed of a Morgan? 7 out of 20. We take all of them, which is 20 out of 20, we would subtract the breeds that are not what we'd like, and we'd be left with 7 out of 20. Okay? Again, my big hope is with story problems. We're not just trying to grab something and say, hey, we've been doing adding and subtracting today, so we're going to add and subtract these. Start to have a rhyme or a reason. Why are we adding? Why are we subtracting? Why are we multiplying? Why are we dividing? That's what I want us to start to think about. All right. Homework answers are here. And again, I will go through and I will rewrite these as improper fractions for us. I'm going to write that over on the side for us. Okay, 11 already had most everything as an improper fraction for us already. So we can look at that, but I'll, like I said, jot these down. So number 5 is going to be 8/3. Again, make sure that all of these are reduced. Again, I am going to point out in problem number 26, that answer did not need to be written as a fraction, so let's not write it as 1. Okay, when we reduce it, it becomes a whole number, an integer of -2. Alright, let's start taking a look. What do we got here? Okay, problem number 11. So number 11, it says that newly cut lumber contains a lot of moisture. Before the wood is used for carpentry or construction, it is usually dried. Suppose a freshly cut board weighs 10.5 pounds. After drying, the board weighs 4 2/3 pounds. What is the weight of water that evaporated? So the first thing it asks us to do is to take 10.5 and 4 2/3 and convert both of these into improper fractions. So this one is going to be 2 times 10 plus 1, which is 21 halves. 4 times 3 plus 2 is going to be 14 thirds. Okay, that's where we begin. Now, it says rewrite these same two fractions using the least common denominator. That's what LCD is, just like an LCM. What is the smallest number that both 2 and 3 go into? 6. So what am I going to multiply this by? 3 over 3. That's going to become 63 over 6. I'm going to have to multiply this by 2 over 2. This is going to become 28/6. Okay, that's part B. And part C says, find the difference. Take how much the board originally weighed and subtract how much the board now weighs. That's going to tell you how much water evaporated out of that. So I'm going to have 63 over 6, and we're going to subtract 28 over 6. So what is that? 35 over 6? Is 35 and 6 relatively prime? Yes, so that answer would be reduced. If I wanted to rewrite it into a mixed number, 6 goes into 35 5 times with a remainder of 5, so I would have 5 5/6 pounds. That's how much water is evaporated from that particular board. Next question we've got. Hayden. Okay, problem number 28. Alright, now the big thing with 28, and I tried to, if I saw this yesterday, get you on the right track before you went too far. The first number was a negative mixed number, and there's some of us that are still forgetting what to do with the negative mixed number idea. So for number 28, we're going to take a negative 4 7/10, and from this we are going to subtract 9 7/15. So, when I take a negative mixed number and change it to improper, what did we say we do with the negative? We ignore it to begin with. We take 4 times 10 to get 40, we add 7 to get 47 over 10. Now you bring the negative back in. From this we're going to subtract. 9 times 15 is 135, plus 7 would be 142 over 15. Now again, I talked with even like Mrs. Gedemy yesterday, because she helped some of you at Learning Center, which is great. She's been talking about strategies. If you want to multiply the first one by 15 over 15, the second one by 10 over 10, you can, but you're going to start getting some ridiculously big numbers. What is the smallest number 10 and 15 both go into? 30. So I'm going to multiply this first one by 3 over 3, and the second one by 2 over 2, and this is going to help me keep my numbers a heck of a lot smaller. So if I take negative 47 times 3, that should be a negative 141. Somebody double check my math there. Does that sound right? Okay. And then we're going to subtract. This is going to be 284 over 30. Now when I go to subtract these, I'm going to need some help here. A little rusty. Negative 435. Yes, no?
No.
25? Okay. Now, right away, I know this isn't reduced. Why? Because they both are divisible by 5. One ends in a 5, one ends in a 0. So now let's divide the top by 5, the bottom by 5. This is the type of work we want to see. What is this? Negative 85 over 6. There is my final answer. Okay, 26. I will have this one. We're going to begin 3rd or 7th period today by continuing to talk about homework. I'm not ready to leave this one yet. Okay?